So this meeting is recorded and is going to be uploaded on public internet. So watch what you're saying. All right, so let's go over some of the items that we have. As you know, we were targeting scheduling framework, some parts of the scheduling framework implementation for this quarter. I sent out a PR last night. I tried to CC most of the people that I felt might be interested in taking a look. This is an early version of what I thought would be an alpha version for the feature. I went back and forth between various designs, including something similar to other plugins that we have in other modules, something like, for example, our event handlers for the API server, where there is a struct that has many members, which are functions, for example. That's the alternative approach that I'm talking about, which is similar to the API server. So that's the alternative approach that I'm explaining now. It's like a struct that has multiple members. These members are functions. So the struct could be like a plugin that exposes a bunch of these functions for different locations. Let's say, for example, it has a member called reserve. That's a function. This function is supposed to be called by the scheduler at the reserve point, and so on. One of the problems with that approach is that, if you register these plugins at a certain order, all of these extension points are going to be called at the same order, because if there is one struct that exposes all these extension point functions, when you register that struct is going to be called in the same order in all of the extension points. I felt like we may want to have different ordering for different extension points. As a result, I changed it to a different design that is actually currently in the PR, where any struct can implement one or many of the extension points and can be registered at each extension point in a certain order. So whatever order you decide, you can keep, you can put that struct in that order in that extension point. So as a result, various extension points can have structs, can have plugins which are not necessarily called in the exact same order as other extension points. So we can mix and match any way we like. That's one of the big decisions that I had to make. There are other important decisions in the current implementation. One decision is to, for example, how to access certain structures such as the scheduler cache. That's also something that I actually decided to register at the beginning of the scheduler initialization. So we registered the scheduler cache in our plugins, or in our plugin set, as we call it in that implementation. And then the plugin set provides the scheduler cache to all the plugins, as they call them. Similarly, for scheduler context, which is basically the data structure that I talked about in the design, in our proposal, in a design proposal for the scheduling framework. This is a structure that allows plugins to communicate with one another. The data that is kept in the plugin in this context survives only for one scheduling cycle, and at the end of the scheduling cycle, it goes away. So this is not great for those plugins that want to have state. This is just mostly for communicating between multiple plugins. This is another design decision. Please take a look. And the last one that I want to talk about now is how to keep state for plugins that want to keep state. So a plugin might want to be stateful and keep certain records for itself that survive all the scheduling cycles. It doesn't want them to go away. So I have actually created examples in that PR that shows how stateful plugins can be implemented. Essentially, a plugin can be struct that exposes some functions, and these functions implement the plugin interface. these structs can have other member variables. These member variables can act as the plugin state, and it's up to the plugin to decide how to initialize them, how to clean them up, or may just want to keep them around forever. So I've created a couple of examples, actually 3 examples, that shows plugins that are stateless, plugins that are stateful, and plugins that are communicating in multiple stages of the scheduling, as well as having like a state that is kept in some of these plugins as their own state, as opposed to something that is communicated with other plugins. So anyways, the PR is out. Please take a look if you're interested, and let's go from there. And if you have any questions, please go ahead and ask now.
Bobby, I may be wrong, but isn't this similar to how we have ordering in admission controllers?
Somewhat similar, yes.
And we have kind of moved away from the design and started with dynamic admission controller because the plugin development kind of became difficult. Do you think we will face the same issues?
So what was the issue there?
So the plugin development, it has to be compiled within the code, and the other problem is with, say, if someone wants to develop that plugin in a separate tree, it becomes difficult.
So we're talking about in-process plugins.
Yeah.
For in-process plugins that we're talking about, there is no way that you can get away with compiling everything together, right? At least in this phase. So we have also the extenders that are sort of like separate components, but for these in-process plugins that we're talking about right now, there's no way out of it really. If you want to have performance, you have to build everything together with the rest of the scheduler.
Okay.
Yeah, I think. I think this is still useful. Last week I have a meeting with some colleagues from my company, and they actually just clone the scheduler code just in order to modify some specific aspects. So if they have this, they don't need to kind of
exactly. So there are many. Given my previous discussions with various users, I guess there are so many people who just want to change a small thing in the scheduler, and maybe a slightly different logic, for example, for one of our predicates, something like that. And in order to do so, they have to fork the whole code and change that like one predicate, and keep syncing everything with that for that one predicate. So our goal was to basically change the architecture so that, yes, you may need to bring everything from the whole code to your own repo and add one plugin maybe, or maybe not actually. We'll talk about that. But let's say that you need to do so. But all that it takes is to just copy everything. You don't need to merge. You don't need to worry about the change of logic or anything.
Yeah.
You just bring everything. You copy maybe one file to a particular directory, and that's it. You recompile, and you have your own plugin or your own scheduler. So we are trying to remove some of the difficulties of maintaining your own code if you want to have custom logic in your schedule.
Yeah, I think, of course, you have to rely on the existing code base. And then if the plugin can support that, you don't need to modify it, just add some folders, then that will be recompiling easier, right? You don't need to handle those kind of conflicts. But if our API got changed, of course, you need to change the files into your specific folders. Yeah.
Exactly. So our promise is that we are going to keep this API, the plugin interface, basically backward compatible, and we provide some sort of same guarantees basically as our APIs, Kubernetes APIs provide. So if, for example, if you look at this PR that I sent out, the interface is specifically placed under a folder called the V1 Alpha 1, calling it an alpha, and then at some point we are going to promote it to beta, and after that we are going to provide backward compatibility as long as we keep the V1.
Yeah, I get that. My question was more on the lines of the same API, is it going to be exposed for extenders as well, or the plugins that are not within the core, or is it going to be different?
No, extenders and in-process plugins are two different things. We cannot really. So, one of the very obvious distinctions between an extender and an in-process plugin is that we cannot share data with those extenders, right? So extenders are another process. So once you have like a single process and all plugins are in that same process, you can share all the data, all the context with those plugins. But once the plugin is outside, then all that sharing goes away. And one of the reasons that actually you get better performance for in-process plugins is the fact that you can actually share context or share the memory and everything inside the process with that with those other plugins.
All right. Yeah. Thanks.
Yeah. Sure. Okay. So let me just send the link to the PR that I was talking about to the chat window.
Oh, I've already sent it.
You did? Okay, thanks. Thank you. Yeah, so let's move on to other items that we had. I have one more update about pod scheduling policies. I had another meeting with Tim Alclair. So I don't know if Yasin is here today with us. He's not. Anyway, I had another meeting with Tim Alclair. We decided that in order to have meaningful and really useful pod scheduling policies, we need to have both static, which means like admission time checks, as well as dynamic, basically scheduling time checks. So, imagine that an admin wants to prevent users from or prevent certain pods in a particular namespace from getting scheduled in zone 1 of their cluster. This is a little harder to specify statically, because when a user creates pods, they may not put any particular policies or any particular constraints on their pod spec to force their pods to not go to, let's say, zone 1. But at scheduling time, we can enforce it. Basically, the scheduler can look at these scheduling policies and say, zone 1 is not feasible for pods of this particular namespace. So we need some of these dynamic checks as well. So the latest development in that area is that we are gonna have like 2 parts. One is like the admission time checks. These checks are for those kind of constraints that are very obvious and are easy to catch. For example, an admin wants to say no pods in this namespace can have toleration with this particular key. And if you put that key in your pod spec, your pod may get rejected at the admission time. But there are, as I said, there are more advanced or more complicated conditions that cannot be checked at admission time, and just by looking at pod spec. So those will be done at the scheduling time. As a result, a pod that violates, let's say, some of the scheduling policies may get admitted to the cluster, but may stay pending. So this is a slightly downside. So the user may not notice that at the admission time that their pods are rejected, but they have to go back and check later and look at their pod status or events to figure that out, that why their pods are pending. We will have a predicate that checks those scheduling policies and put an update in the pod events that the pod was rejected for violating scheduling policies. Any questions about that? Okay. So next item, taint-based eviction. I know where you had sent some updates or some additional end-to-end checks and tests for taint-based eviction. I think that's great. Thank you very much for sending those out. And Ravi had been helping with that effort as well. Thank you, Ravi, as well. So if you guys have any further updates, please share them with us.
Yeah, so right now, I think in the code perspective, the E2E is not the PR, unless we got other issues reported. So next, I will raise a document PR to address all the changes in the Kubernetes website.
Okay, thank you. Okay, let's see. Yeah, so
yeah, but maybe well, my personal opinion is that the name 10-best eviction, I've talked with Ravi before, the name is somewhat misleading because it caused me to think that it is the feature that evict the path, right, based on the 10. But actually the 10 behavior is actually not decided by this feature enable or not. So maybe you should mention a little bit in the document. Let's see.
Yeah, it would be great to do so. Yeah, sometimes naming is hard. I don't know if you have better names, you might have a chance to change it now. But sometimes it's hard in one way or another. It could be confusing without further explanation in the documents. All right, so we're still looking for one item, and that's deprecating critical path annotation. Actually, I might do it myself. I don't think we need to do much for that. We just probably need to mark it as deprecated in this release, and then in the next release we can.
Yeah, it's probably going to be a docs PR change mostly.
Yeah, exactly. So yeah, if anyone has the time, please move forward. Otherwise, I will try to kind of squeeze it in my plans.
Okay, I'll do that.
All right. So Ravi, I know that there was one issue with limit priority function that you sent out a PR to fix that, right?
Yeah, the problem seems to be with the default, we have an algorithm provider as well, right? In the defaults.go code, there is no way to, as of now, there is no way to register priority functions. There is a way to register predicate functions for the default provider, but we do not have it. So I have added that function as well. Whenever we use the default algorithm provider, say if we want to enable a particular priority, there is no function to do it at this point of time.
Oh, really? I thought we had something that specified the set of enabled priority and predicate functions, right?
We have one in the, so the way it works is there is a init.go, and in that init.go we have a function which calls for default predicates and default priorities. If we have it in default priorities, it will go in. But if you don't have
we're talking about end-to-end testing in particular, right? Generally just scheduler or?
So when I was looking into how to fix that, so the main problem there is the function itself is not enabled in the default provider. The resource limits priority function itself is not enabled in the.
I see. Oh, okay.
In the default provider, that's where the problem is.
I see. Okay. Yeah. All right. Thanks. So I will take a look at that PR. Is there any PR that needs my immediate attention? Okay. Please, if there is, please send them on Slack to me, because sometimes I just forget to go and look at all the notifications that I get from GitHub. I guess these are pretty much all the items that we have. I don't think that we can do much about the scheduler in this release.
Yeah. Right? Yes, Bobby, sorry. I did not find time, and I don't think I'll be able to do it before the end of this release. But we can try aligning our releases with the Kubernetes releases too.
Yeah.
The change that we could do, instead of promoting it and then, instead of moving it to SIG's repo, like Kubernetes SIG Scheduling.
Yeah.
This point.
It's fine. I mean, this release is a special release. First of all, it's very short, and there is also some. I mean, we prefer not to add a lot of features in this release, so it's okay. We can do it in a different release. And I mean, we wouldn't probably enable the scheduler by default, anyways. But it's. I mean, there is always a chance to do it next cycle. So there was one more item, and that was moving balanced number of attached volumes to beta. I don't know if you were able, Ravi, to measure its performance.
Yeah, I have done some benchmarking.
Uh-huh.
I will provide a PR for it, but I do not know if that data is going to be enough to move it to beta.
Okay, yeah. Please share those with us once they are available.
Sure.
Okay, I guess these are all the items from us. Deepak is here. I don't know if Deepak has any updates for us on the Poseidon side.
Hi, Bobby. Hi.
Hi.
So, yeah, so we've been, we are in the process of cutting a release that includes the gang scheduling, the initial version of gang scheduling, which we developed. And we had that thing mixed up with the max part thing, actually, the max part feature. And we ran into some problem with the max part, actually. So we initially, because the way informers work and all the threading issues, so there was some sequencing issue and all that, actually. So initially we thought that we will take out, we'll just do the max part within firmament. But even that doesn't work, because there are some cube system parts are on the same node. So the count goes, so the test failed because of that. So we don't have any choice other than getting all the parts from Kubernetes. So we have the code, but I think there are some corner cases. So we need to do some more testing. So we have to back out the max part change, but we are doing a release by the end of this week to do the gang scheduling thing, actually.
Okay.
And yeah, go ahead.
No, so I said just that's nice. So what is the issue with max part? So is it just
no, it's not it's not. No, I think there's some not a major issue. So essentially we define formers, and then there was some sequencing issue, and we just wanted to have, so the reason I wanted to keep max part separate, because we were not able to resolve those issues, is because internally, actually, there's our product group guys are very interested in this gang scheduling and all the bulk capabilities. So they wanted to look into that, how viable would that be as part of the product. So they're looking at it from that. So I wanted to do just a release for the gang scheduling.
I see.
And the fact that Firmament does bulk scheduling, that is very helpful for AI jobs,
Yeah, exactly.
Yeah. So that's what is going on. Yeah. So that's why I wanted to do that. And then it's not a major issue. We'll be able to do that next week.
Sure. So with your release, are you gonna go ahead and write some documents about how to use
definitely,
and maybe how to?
Yeah, we want to make sure.
Yeah.
Yes, we definitely going to do that, and we do working on the helms and charts as well, actually. So hopefully we'll have that done too. So we want to make it more simpler, the installation. We will let you know. We're just making sure everything is in place, and then we will inform you then.
That's great. Okay, thank you so much. All right. Is there any other question, comments, updates? No. Going once. Twice. Okay. All right.
Bye-bye.
I guess you guys get 4 minutes of your life back. Thank you very much for attending. See you some of you folks next week. Bye.
Thank you. Bye.